can't seem to stream this, so I'm going to do this quick problem. Let's see, you have a pipe sitting here, and somebody was able to put a delta P of 25 psi across this. Question would be, what's the flow rate? Either V, velocity, or Q. In a pipe like this, and in general states, you label each location. Here, you have all your losses. Okay, I'm going to just put a box there for the minute. In the general state, the pipe diameter didn't change, so these remain the same. The elevations remain the same. So what you end up with is P1 minus P2 over gamma is equal to whatever this loss was. Turns out this is minus F over D, V squared over 2G. So you have this. Now, we've already decided this is 25 pounds per inch squared, which is 144 inches squared over feet squared over 62.4. If it's water, it may not be water, but in our case, pounds per cubic foot. Turns out the units here will become feet. Unit F, the length of 1,000, diameter of 2 feet, V squared, which you don't know, and 2 times 32.2. Now, I already copied these diagram here. I'll make use of that in a second, but for the time being, I've got to basically solve for this. So when I end up with this 25, 144, 62.4, move everything across, I get 2, 2, 32.2. This came from right here. And then I had 1,000. That came from up here. Oops. And then I had an F buried with it. And so I end up with something like this. Now, if you start with E over D of 0.001, which is what was given here, in this particular problem, you realize 0.001 is right here. So for a Reynolds number of here to here, and even above, I get 8. If I got a Reynolds number, came up here, crossed the line, moved to the left. Reynolds number came up here, crossed the line, moved to the left. I move to the left every time, and I get a 0.01. In other words, what you'll notice in this region, F is equal to fixed, or F is only a function of E over D, only in this region. Okay, so that being the case, that's going to be my first guess, and I repeat myself, first guess for this. And make sure that the recording is still going. It's still going. I'm getting audio out of it. Okay. So what we'll do is we'll come in and put V is equal to, or here we'll start our process. Process 1, F is equal to 0.02 from the diagram. Process 2, velocity is equal to, from this equation, okay, so I had this in here once. Okay, I don't have, okay, so here, let's do this. So I'll say F is equal to 0.02. I think I was writing this before, but I had 10 instead of 25. So now I have 25. Okay, let me make sure. I think I'm okay. So I get 19.275. The next thing I'm supposed to do is come up with a Reynolds number, rho, velocity, diameter over mu. In our case, this is water, 19.275. This will end up being feet per second. Diameter of 2.34 e to the minus 5. So we'll make use of that again. The Reynolds number, 1.94 times the velocity times 2 about 2.34 e to the minus 5 gives me 3,000,000. 3.2 e to the 6. Now, here's 1 e to the 6, 2, 3, 4. So here's our target, 5, 6, 7, 8, 9, and 10. So what I'm supposed to do is draw it up, hit the line that is my E over D, and then immediately run to the left. So for this particular case, it turns out that it is the answer. We're done. There's your answer. Let's say for chance, just out of curiosity, what would happen if E over D was, say, smooth pipe equals to 0. Smooth pipe. Now, this is not what the problem statement was given, but we're going to go on this. So state 5 would be, I'll take my Reynolds number, go up until I hit that, and then we go straight to the left. And I would say, I don't know, 0.009. We'll just use that, 0.009. So F is equal to 0.009 from Moody's diagram. Okay, what we'll do, I'll go back and say F is equal to 0.009. Go back into my velocity. I get 28. Now, let me just carry it as 28. Around 28. But the thing is it's there in full view, so we'll go back. Now, the only thing I have changing is the Reynolds number, and it looks like 4.7. Reynolds number is equal to 4.7 e to the 6th. This moves us to the right on the movie diagram here. So there was my 1, there's my 2, 3, 4, 5. So somewhere around here, I would cross that and I would come back off of here. So it would sit right there on that line. I'm going to guess, I mean, I can't really tell the difference, so I'm going to say 0.008. And technically what you're supposed to do, step 8 would be, the friction factor was 0.008. Step 9 would be with the friction factor, 0.008, and I may be off on that. And the velocity would be 30. Reynolds number will be 5 e to the 6, which was about close enough to there. Call it quits. So the velocity is going to be around 30 in this case. I hope that basically gives you an idea